Hello everyone, I am Dr. P. Kumari, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, I would like to discuss about formation of partial differential equation by eliminating arbitrary functions. So here, before going to what is formation of partial differential equation is, partial differential equation can be formed either by eliminating arbitrary constants or by elimination of arbitrary functions from a relation involving three or more variables. So here, in this order, in the eliminating arbitrary constants, here we are having two conditions. One is number of arbitrary constants is equal to number of independent variables. Then we will get independent variables. Then we will get first order PDE. So if you have number of arbitrary constants, eliminating number of arbitrary constant is greater than number of independent variables, then we will get second order partial differential equation. So, but here coming about arbitrary constants, what happened here we can observe. So, here PDE is same as the number of arbitrary functions present in the solution. So, order of the PDE is same as the number of arbitrary functions present in the solution. So, now we are going to check about the elimination of arbitrary function, how we can eliminate, how we can form the partial differential equation with the example. We can observe here given, find the partial differential equation by eliminating arbitrary functions from z equal to f of x square minus y square. So coming to the solution, you can observe here given z equal to f of x square minus y square, f of x square minus y square. This is the given function. So now, first, according to the procedure, what we have to done, first step we have to do differentiate partially with respect to x. So next step differentiate partially with respect to y. So like this we are going to simplify after that to form a PDE. So according to those steps I am doing here. First, the given equation is z equal to f of x square minus y square. Now I am doing first with respect to x. Dou z by dou x equal to f derivative is f dash. F derivative is f dash. So f dash of x square minus y square. So for the inner part again we have to do the differentiation. So here when I doing the partial differentiation with respect to x, y treated as constant. So according to that I'm writing here the x square derivative is 2x minus y square is 2y, but the y is constant, so this is 0. So finally I got f dash of x square minus y square into 2x. So what we got here? F dash of x square minus y square into 2x. I am taking this equation as 2. Now I am doing partial differentiation with respect to y. So here you can observe dou z by dou y equal to, so derivative of f is f dash, so f dash of x square minus y square. So now here when I am doing with respect to y, so x is constant. When I am doing with respect to y, x is constant. So now, so x is constant means this is 0. So minus y square derivative is 2y. So finally I got here f dash of x square minus y square into minus 2y. X square minus y square into minus 2y. This is the only equation I got here. You can observe into z by dou y, f dash of x square minus y square into minus 2y. So I am taking the given equation as 1. After doing partial differentiation with respect to x, that equation I am treated as taking as 2, and after doing with respect to y, that equation I am taking as 3. Now I am going to simplify these 2 and 3 equations to form a PDE. So now what I can do to eliminate the function from these two equations, according to simplification, we can eliminate the arbitrary function. What is the simplification I can do? For example, here I am taking 2 divided by 3. So second equation, what is the second equation? You can observe here dou z by dou x. So dou z by dou x equal to f dash of x square minus y square into 2x. Next, third equation is dou z by dou y. So dou z by dou y equal to here f dash of x square minus y square into minus 2y. So now here when I am doing division 2, equation 2 divided by equation 3. So here f dash of x square minus y square will be cancelled, and here 2 will be cancelled. Finally I got dou z by dou x by dou z by dou y equal to minus x by y. What I got here? Dou z by dou x by dou z by dou y equal to minus x by y. So already according to the notations, p equal to dou z by dou x. According to the notation, small p. So q equal to dou z by dou y. So I'm going to replace these two values here. So finally p by q. So this is p by q equal to minus x by y. I got p by q equal to minus x by y. So now I am going to do the cross multiplication here. So here cross multiplication I am doing. So p into y equal to minus qx. So nothing but now p into y plus qx equal to 0. So this is our required PDE. This is our required PDE. So already given one information, what are the number of arbitrary functions present in the equation. So based on that we'll get the PDE order. So one function is present here. So that means I got first order PDE. So this is our required equation, Py plus Qx equal to 0. This is first order partial differential equation. So this way we can eliminate the arbitrary functions from the given equation. So to get the better understanding about formation of PDE by eliminating arbitrary constant, I am going with one more example here. Please observe series. Obtain a partial differential equation from equation z equal to x plus y into pi of x square minus y square. So given equation is z equal to x plus y into pi of x square minus y square. So now according to the steps, first I have to do partial differentiation with respect to x. So according to that, when I am doing with respect to x, y treated as constant. So here u into v formula is there. Here u into v. So what is u? U is x plus y and v is pi of x square minus y square. So according to this I am doing partial differentiation. So derivative of u into v formula is u into v dash plus v into u dash. What is the formula? U into v dash plus v into u dash. So according to that I am writing here first u. U is x plus y into v dash. That means derivative of v. So Pi derivative is pi dash of x square minus y square, pi dash of x square minus y square into, for the inner part also we have to do the differentiation. With respect to x I am doing, so x square derivative is 2x minus y treated as constant, that is 0. So this is the u into v dash plus v into u dash. What is the v? Pi of x square minus y square into u dash, derivative of x plus y, that is 1 and y is 0. So finally I got here dou z by dou x equal to x plus y into pi dash of x square minus y square into 2x plus pi of x square minus y square, pi of x square minus y square. That is only we wrote here. So already we know the notation about the PP is noting with dou z by dou x. So now this is our first equation, that is when we are done with respect to y. Now I am going to do with respect to y now. So according to same formula I am going to do with respect to y. So when we are doing with respect to y, x is stated as constant. X is stated as constant. So same form we can observe here. Here x is u equal to x plus y and v equal to pi of x square minus y square. So now I am doing dou z by dou y. So what is dou z by dou y? U into v dash. So u is x plus y into what is v dash? V dash is pi derivative is pi dash. So x square minus y square into, here I am doing with respect to y means x constant. So this is 0 minus y square derivative is 2y. So this is u into v dash value plus v into, so pi of x square minus y square into derivative of v. So derivative of v is x is 0, y is 1. So finally I got dou z by dou y equal to x plus y, dou z by dou y equal to x plus y into pi dash of x square minus y square into minus 2y plus pi of x square minus y square. This is our q, that is q equal to dou z by dou y, that is x plus y into pi dash of x square minus y square into minus y plus pi of x square minus y square. So this is the p and this is the q. So now after doing the first step, what we are doing in the last step? We are going to simplify these equations to form a PDE. We are going to simplify these equations to form a PDE. So what is the simplification I can do to form a PDE according to the given equation? So for the simplification we are having so many ways. So according to the equation what we got, based on that we can do the simplification, we can do the division also, we can do the substitution of those values also, and we can do some replacement of values also, like that so many ways are there for the simplification. So here I got this equation, I am writing this one as p equal to x plus y into pi of x square minus y square into 2x plus pi of x square minus y square. So here I want to replace the value of pi of x square minus y square. So where I can get this pi of x square minus y square value? So already in the equation, I am having z equal to x plus y into pi of x square minus y square. From this, I can write pi of x square minus y square equal to z by x plus y. Pi of x square minus y square equal to z by x plus y. So I am going to replace this value in the equations what I got before. So here, so p equal to x plus y into pi of x square minus y square into 2x. In place of pi of x square minus y square, I am going to replace z by x plus y. So now from this I am going to simplify. I got, when I am sending this value to the left side, got p minus z by x plus y equal to 2x into x plus y into pi dash of x square minus y square. So this is our final equation after simplifying this. Now I am going to simplify the second equation, that is q also. So q equal to, what is the equation? Q equal to x plus y into pi of x square minus y square into minus 2y. What is here? Minus 2y into pi of x square minus y square. So same as like that, I am going to replace z by x plus y in the place of pi of x square minus y square. So q equal to x plus y into pi of x square minus y square into minus 2y. So now in place of pi of x square minus y square, I am writing z by x plus y. So finally I am sending this value to the LHS part. So I got q minus z by x plus y equal to minus 2y into x plus y by pi dash of x square minus y square. So now I'm going to do the simplification. We can observe here. So I am doing the division here, as like I am doing the division here. So this equation divided by next equation. So according to that, I am writing here. So p minus z by x plus y equal to p minus z by x plus y equal to 2x into 2x 2x into x plus y 2x into x plus y into pi of x square minus y square, pi dash of x square minus y square divided by q minus z by x plus y. That value is minus 2y into x plus y into pi dash of x square minus y square. So here pi dash of x square minus y square will be cancelled, x plus y will be cancelled, 2 will be cancelled. So finally I got p minus small p here, p minus z by x plus y by q minus z by x plus y, that is equal to minus x by y. So that is all I got here. So now I am going to do the cross multiplication. I am going to do the cross multiplication to get the PDE. So to get the BTK, now I am simplifying here. So P into x plus y minus z into y equal to, here please see this simplification. So P into, when I am doing the cross multiplication, so P into x plus y minus z into y e plus q into x plus y minus z into x, that is equal to 0. So finally I got here, when I am taking the common x plus y, I got here py plus qx minus z into x plus y equal to 0. So this is our required partial differential equation after eliminating the arbitrary function. So this is the way we can eliminate arbitrary functions to form a PDE. So finally, after simplification, we got the equation by the notation. So this is py plus qz equal to z. So this is our required partial differential equation. So I am going with one more example to get the clarity about the eliminating arbitrary function. So obtain partial differential equation from the equation z equal to f of x minus 80 plus f of x plus 80. So here given we can take this one as z also or phi also. If you are writing y here, we have to follow the notation according to that. We are having z, we have to write that z here. So here I am taking y equal to, so f of x minus 80 plus f of x plus 80. So according to the procedure, first I am doing with respect to partial differentiation with respect to x. So f derivative is f dash. So f dash of x minus 80 plus f dash of x plus 80. So now here two functions are there. I am doing here these two functions. To eliminate these two functions, I have to do the partial differentiation two times. If one function is there, so already I told you simplification will be different according to the given problem. So here I am doing the same with respect to x again. So dou square y by dou x square. So here dou square y by dou x square equal to f derivative is f double dash of x minus at, f derivative is f double dash of x plus at. So dou square y by dou x square equal to f double dash of x minus at plus f double dash of x plus at. Now I am doing again with respect to here what are the independent variables I am having. Based on that I have to do. So here I am having x independent variable and t independent variable. So that's why I am doing here with respect to t. So dou y by dou t equal to, so f derivative is f dash, so f dash of x minus at into minus a. So here derivative of x is 0 and here minus a is the constant, derivative is 1 and derivative is 1. So here this is minus a into f dash of x minus at plus f capital F derivative is capital F dash into x plus at. So x is 0 plus a. So finally I am again doing the partial differentiation with respect to t. I got f double dash of x minus at into minus a whole square plus f double dash of x plus at into a square. So I got here dou square y by dou x square value and dou square y by dou t square value. So now based on this I am going to simplify these two equations. So now dou square y by dou t square equal to, here I am having the a square common. In this equation I am having the a square common. So a square, take the common, then remaining f double dash of x minus at plus f double dash of x plus at. So here a square into, already I am having this value, that is nothing but dou square y by dou x square. So in place of this I am going to use dou square y by dou x square. So finally I got dou square y by dou t square equal to a square into dou square y by dou x square. So this is our required PDE after eliminating the arbitrary functions f of x minus at plus f of x plus at. So this is our required solution. That is nothing but required formation of partial differential equation. So dou square y by dou t square minus a square into dou square y by dou, dou x square equal to 0. So this is our final PDE after eliminating arbitrary constants. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.